different kind of being the recipients by the kinds of experiments we're doing in school. MIT has a variety of departments that are so powerful that they have the potential of radicalizing what we do in design and in the architecture department. Even the way that we've structured our curriculum around workshops and other kinds of collaborations in a way foster and encourage. So we're situated perfectly for the kinds of things that only MIT can do.
The invention of the geometry, the process, and the material that constitute that artifact. New materials in an informed way. The Emergent Materials Group and the Urban Metabolism Group share a central deal in the area of foamed materials.
The work really tries to address that there's two main paradigms. What can you physically construct, or what can you build? The work really tries to traverse all scale lengths. It tries to work from the nanoscale, which is traditionally where we see self-assembly and biological examples, that and say, can't we use this phenomenon of self-assembly as a new paradigm for building things at large scale? We work with any type of material, synthetic or natural materials. Combine those two together, they can respond to energy, and the energy sources can be heat, shaking, gravity, pneumatic. So you can use any type of energy, and when you mix that with the geometry and material properties, then they can respond and they can change state. Primarily, it will first be applied in extreme environments, scenarios where it's difficult to build. The research and the practice is really about cross-disciplinary collaborations between designers, scientists, engineers, working on this phenomenon at different scale lengths.
The focus of our work, at least at an installation called Totems, which in a way is a kind of proto-architecture, not quite architectural, not quite installation now, which is an anechoic chamber, and the anechoic chamber uses industrial felt both on its exterior and as a way to absorb sound on the interior.
I'm bringing a kind of discipline
in the city around issues of mobility for the year 2030. It seems now more and more necessary that our environments
heat, produce light, or communicate information. The challenge, I think, for the discipline of architecture today isn't in digital fabrication when we move fluidly between digital and physical realms. How we use materials and not waste them, and how we form materials, and how we transport them. But not settling for those norms, instead innovating to both accept
demonstration of the power of computation come real time. Then in the robotic manufacturing work, we're looking for sort of power, information and material all coming together, but with control directly at the architect's workplace. So we're developing tools that allow architects within their native software like Rhino